Hey everybody, Adam Savage here in my cave with a one-day build that is a tool-based. I spent a lot of time over the summer of COVID, what they call chasing zeros, utilizing my mill and my, it's back behind there, but my lathe a lot. And I started to add and augment my collection of tools that go with them. And one of the parts of that collection was the lathe chucks, the different ways one can hold on to work. I got through 30 years of using a lathe, using almost exclusively a 3-jaw chuck, which is, I think, a fairly standard experience. But once I started increasing my ambition on the lathe, I needed more ways of holding on to stuff. So for an example, here are 3 lathe chucks and the holder I built for them last summer. That's the standard 3-jaw I used for a long time. Well, actually, that's a newer 3-jaw. That's a 4-jaw for precise alignment of non-round work. And this is a collet chuck, a beautiful hard-edge collet chuck for 5C collets. Allows you to hold on to work with, if you dialed it in with high repeatability, but also it doesn't damage the part to hold on to it. That's one of the advantages of collets. There is another whole class of holders within machining using the mill or the lathe that are magnetically based. And you've seen me use some magnetic indicator bases, those little things that you can turn a dial on and like this is one. This is a fence for my bandsaw, and you turn these little knobs, and they align some magnets inside and saturate the outer casing, and you get something holding on way stronger than you think is possible. And I was a little bit dubious when I heard that one could use magnets to hold on to stuff on the lathe or the mill, but the whole world does it every single day. And I wanted to jump into this plasma pool, and I found a pretty good deal on what looks like a seized magnetic chuck from eBay. Here it is. I literally just cut the top so I could confirm that's what this was. This one-day build is me restoring this chuck and making it work for my lathe. Yeah. It's going to use the parts washer. We're going to be cleaning some stuff, taking stuff apart. This thing is old and beat up. I might have to soak it in some rust remover tonight. Yeah, let's get into it. Within a magnetic chuck, there are magnets, and there is always a mechanism by which those magnets are moved towards each other. So underneath this, you would have, sometimes it's this, but something that moves only like a 1/2 inch or maybe even less, like 3/8 of an inch. But that movement allows the magnets to connect to each other and creates a strong magnetic force. Right now, very little magnetic force on the front of this. And wow, it is definitely an old piece. Okay. So inside here are some magnets in an arrangement that is really particular. There is a key for activating this that I do not have. 53 pounds. That's what this weighs. Let's start taking it apart, shall we? Nope. Off by 1. Oh, I'm off by 2. Okay, let's get some... Yeah. There's going to be one of these for each of the 4 pins. Pull those out, and then these should unscrew. Ah, yes. Let's break out the parts washer. Use that to get the grease off. The first time I took apart a chuck, I was like counting the rotations of these things because I had no idea how mission critical their placement was. Later on, I discovered that the spindle lock has a fair bit of, that's what this is. That's the type of attachment this is. Basically, these pins go in and you get to tighten them down with the mechanism. It's very robust and repeatable. That does not require high precision of reassembly. Oh, come on. Oh. There we go. So this is the backing plate. My lathe is a D1/6, if I remember correctly. That defines both the diameter that these are on and their size. What's interesting is not all, well, like on my lathe, I have actually 6 pins on the lathe, but not every chuck needs them. For instance, for the hard-inch lathe, which is lathe chuck, which is, you know, you're never doing work that's bigger than like 1.25 inches, you only need 3 pins. For the 4-jaw, where you might be hogging a lot, you want more pins. But for the magnetic chuck, again, the size of your mechanism is dictated by how much work you can do on it. And a magnetic chuck holds well, but not like, you know, not like the clamping force of a chuck. I think that one might be this. And it is! Woohoo! Okay. Nope. I got another one of those somewhere. All right. Let's get a little bit of meat on there. Whew. And I think this is only taking off the backing plate. Wow. All right. That got it. It's tougher than I thought. Oh, I love a little momentum. Now, on the theory that there may be a specific... Wow. I haven't removed that much weight, have I? All right. That's the backing plate. I'm just making myself a reference mark so when I separate this out, I can put it back to that reference mark. Oh, look at that. I didn't need to work so hard. That was all just gonna happen fine. Wow, wow. Oh my gosh, okay. I'm just gonna wash this for a minute. It's always good to remove all the grease using a parts washer before you put this thing in rust remover because the grease is going to inhibit your rust remover. Oh man. Woo-wee boy. Let's pull this in. Yes, nice. This is a great technique for removing recalcitrant screws. Hopefully, all I have to do here is clean out all this gunk and build a locking handle for it, and then I should be good. Oh, glorious. Hex, yeah, oil. Okay, so that's where oil goes, and that's also where oil goes. So we can pull both of those. Let you move. Wow, yeah, it really needs a little bit of tender loving care. Ha! That one I did get right on the first try. Nope, I didn't. Ha! Wrong. Okay, it has marks. It has marks, and those marks have been, yeah. I don't feel any movement happening. This thing could be completely rusted together. Oh, there are 4. I'm dumb. Here we go. Oh, it's even another one. Hey, boss, how many sizes of Allens should I be using? Use them all. There we go. 2. Are these for splitting it? Okay. Right. It might be a while before I get any heat moving through this thing, it being a solid monolithic block of metal, but we'll see. We'll see what we can do. I'm actually scared of this thing hurting me. I am feeling some movement. Okay, so I cobbled together a tool. I'm sorry to tell you I did this off camera. I slipped some gauge pins into the hole until I determined that it was 0.35, literally 0.35 inches in diameter with a 5/32 hole in it. So I took a bit of 5/32 high-speed steel. That is the basis of the new tool I will make for activating this. And once I applied this, it seems pretty activatable. It's crunchy inside, but it's grippy, but it's not crunchy. So when I move the mechanism, I don't hear, which would be bad, obvi. No, what I hear is like, So I did a bunch of croil. Again, this is some of my favorite stuff for penetration and working out recalcitrant bolts. And now I have it sitting in rust remover. There we go. Now I have all the parts of the chuck sitting in rust remover because I determined that I think it actually works. The biggest issue I determined, oh, right. My rust remover is this stuff, Evapo Rust. It's reusable. I've got all the nuts and bolts sitting in it. Oh, yeah. Tomorrow they should be all really lovely. I discovered that one of the ways in which magnetic chucks fail is they get swarf and grinding dust and all sorts of crap inside, and that leads to more tension on the system. And what the system is in fact, it's usually a cam with a lever on it that moves a full set of magnets somewhere between 1/4 inch and 1/2 inch. It's a very small amount. But what it does is when it lines them all up together, you get this huge amount of magnetic gription, and when you put it back, you don't. For grinding or surface grinders, where this failure often occurs is that even though you're moving the lever this way, the inside mechanism is moving shorter and shorter. I've been doing a lot of research on people rebuilding their magnetic chucks. And there's a lot of myths out there. Like people are like, you can't let it lose its magnetism. And it seems that my chuck is it seems that the chuck that I bought on eBay is functional, if a little bit clearly filled with some stuff. So I've got it soaking overnight. I've parts washed the grease off of all the other parts. Tomorrow I'm going to pull it out and test operation, see if it feels a little smoother. Then I'm going to break out my welder and put this tool together for the lever arm. I'll have to think about what that handle's going to look like. I'm going to put some tools away. I would play music, but Alexa's not cooperating today. So it looks like I've got the chuck mostly working. If you're wondering what I've been doing here, this is my surface plate. This is a piece of granite that's ground to an extreme flatness. And after stoning, is using this India stone, that's a rough and the red is smooth, to take down all the burrs. I have indicated this on the plate, and the indicator is this. The indicator is this one. It's my finest indicator. It measures to 2 microns, 1/10,000th of an inch. And it's showing me that this chuck is about 1/1000th thicker on one end than the other. And you know what? On a big 15x40 lathe, that is good enough. Seriously, if it's not good enough, tell me in the comments because I will check it out. Machinists of YouTube. Specifically, it strikes me that if I'm within 1 thou across the full width of this thing, I'm pretty pleased with that. It operates. I have to make its wrench, but I'm about to put its pins in, and the next step with this is to put the pins in, 1, 2, 3, 4, and then chuck it into the lathe and indicate it again to see how flat it is on the lathe. And I may end up adding 1,000th spacer in between a couple of these places. We'll see. Right now, it doesn't seem like it warrants that. But I'll know more when I chuck it into the lathe. I like that. Each of these kind of have a place they like to land. There's a ridge machined about 250 thou above the bottom of these pins, and your goal is that is sitting right about the level of the back of the chuck when the notch for the cap head screw lines up. And you will find these by and large have a kind of position they like to get to. Once I try and lock these on the lathe, if I'm off by a little bit, I may have to turn some of these one revolution up or down to get it to work, but that's all part and parcel of a spindle lock chuck. That was an interesting sound. Oh, you know what it was? It was oil being squeezed out of 2 very precise surfaces. Okay, so I've assembled this back together. The only thing I haven't assembled is a set screw arrangement here next to the activator. Just because I suspect the set screw is a limit, but until I have an actual tool, I don't want to mess with it. So, to the lathe! This is the spindle that the spindle lock chucks lock to. And it is absolutely mission critical that this has no burrs and is clean AF. You even want to feel inside each of these holes to make sure there's no swarf in there. Excellent. All right. We're going to try out our chuck. 53 pounds. This is one of my lighter chucks. Oh my gosh. All right, come on. Okay. Excellent. God, it's nice to load such a low pro chuck in here. So, that has no spindle lock behind it. This does. Okay. So when I lock my spindle lock, I tighten everything a little bit. And, oh, that one doesn't get anything. That one does. Yep. And that one does. That one doesn't. That one does. That one does. Oh, no. Oh, wait. That one does. Time to bring out another indicator. And this one uses a mag base that works on the same principle as the mag chuck. I simply put it down, lock it, and it's well. All right, so if I'm going to do this, I want it to be like that. Good. All right, lock that down. All right. So every movement here is absolutely weirdly critical. That's it. Okay. We're zeroed out. Down by about 1,000. That's not bad. 1,000 between 1,000 off. I don't expect that I can get way better than that. So I'm not going to try. I'm pretty pleased with that. But now it's time to mess with the operation of this thing. Excellent. Take this away. Oh! Oh! Oh, I can barely move that. And then if I move it, I can. Okay, I think. Okay. So now I am going to be soldering together some of the parts. The little twisty here with the notch in it, that gets a bar soldered into it. I've cleaned everything with acetone. And I'm about to So there is, come on, that's the business end of the tool. I'm not sure I've gotten the wicking I want, but I can affect this later should I need to. Now it's time to make a handle for it. I'm going to use this old wrench handle because I like its style. I like the cut of its jib. there you have the tool. It is machined out of a piece of, not high-speed steel. This is high-speed steel, but this is not. All right, let's go try it. All right, I'm going to attempt to turn this on. There we go. That is a suitable key for my magnetic chuck. And when I, wow. Ooh, yeah. Just want to see if I can make a light cut in this at all. To see if what I have is an actual chuck. Okay, so all right, so here is the measurements I need to determine. I have a primary diameter of the main body of the key, and then I have the key itself, this extra bubble. I need to figure out the diameter of this, that's this measurement. I need to figure out the diameter of this, that's this measurement. And then I need to figure out the overall distance here. And that should tell me how far into this piece to cut this radius. I believe this radius is 5/32. And so I am going to, Alexa, what is 5/32 in decimal?
0.16 S decimal representation is 0.16.
0.16. And so this distance is 0.42. All right, so here are my critical measurements. Now, what I need to do is I need to do is A plus B minus C tells me how far in to make this cut. So Alexa, what is 0.16 plus 0.35?
0.16 plus 0.35 is 0.51.
Alexa, what is 0.51 minus 0.42?
0.51 minus 0.42 is 0.09.
There we go. 90 thousandths is apparently the depth of this cut. And we'll cross-check that. First, I need to turn a piece to this diameter. I need to turn another piece to this diameter. Yeah. But that gives you the basic lowdown on how I'm going to make this tool. Oh, then I'm going to embed it in the end of this wrench like I did before. This is I think that's a 3/8 hole, and I'm going to drive a nice spring pin in the end of that. And that should be the end of that. I feel like such a dumb cough sometimes. It's just that trying to throw good money after bad, where you're like, I can make this work. I only need to do this one other thing. So the issue that I was having, the reason my key did not work is that I made this piece, I worked out these measurements, I made that cut, I took this piece that fit in that cut and it fit in the key slot. My issue was these are two totally different kinds of steel. This one's high-speed steel and it would not braze to this mild steel. So I am now going to be using two pieces of normal, regular hot roll steel, mild steel to make this key, and it should be just fine, and they should brace together nicely. In theory. Okay, I have turned the outer part. Is it? Oh! I have turned the outer part here, and I've turned the inner part. Before I separate everything, my goal is that, hang on, I want you to see this. There you go. Okay, so I've cut a notch out of here with this end mill here, this one, and I have made a piece of steel that fits that notch exactly. It's ever so slightly undersized from 5/32. And now my goal is that the overall width of these two is right around 0.42. And, oh, look at that. Dude. I'm pretty pleased with that. All right. So now the thing is, I want to braze these together and then slice off the, yeah. Okay. So, yeah, let's see about doing it. That looks like it worked. I feel like I got that. So I put this together with silver solder, and I feel like I've been using silver solder for decades, and I still feel like each time I'm figuring it out brand new. With parts like this, I don't need a ton of mechanical strength. I just need a certain amount of reliable grab. I don't need mechanical strength because I've got a cylinder that's sitting in a pocket. There's not a lot of like torque trying to pull it out of that pocket, especially if my fitment is as good as I think it is. So I took a piece of silver solder and I hammered its end really flat. I placed that end between the cylinder and its little cylinder pocket. Then I clamped them with some clamping force on the theory that once I heated that silver solder up to melt, the clamping force would push even further and bring the two pieces into perfect orientation. And it looks like that has happened. I will make the measurement. I'm hoping it is 0.42, and then I will test fit it in this thing. And hopefully we'll get there. That will be what is required. Required. All right. I'm going to slice this end off and see how this fits. Okay, so now it's the moment of truth. It is, does it fit? Does it fit in the keyway here? Oh. Yes! Very happy. Very happy. We are pleased. There it is. There's the key for turning my mag chuck. It is not pretty. I'm under no illusions that this is pretty, but it works. And that is the main dealy bob. I'm very happy. So now I'm going to cut this and install this into my wrench, drive a through pin for some shear force, and then we should be done. So the tool is almost ready. We've got the business end here. It fits into the 3/8 hole I've driven here. It is going to be with the nub on the inside because that's activation on, off. And in order to secure this, I'm going to use a roll pin. Now, yeah, I actually think there's enough meat for the torsional load on this load pin. It's a shear force. It is a shear force. So I am turning on this. I don't think that I'm going to shear through this roll pin. That's my theory. Let's see if I do it. So this is an OD of 0.175. I'm going to go for 0.165. All right, I was nervous, so I actually did the pin off camera. I just forgot to move the camera, but there we go. These parts are all in orientation to each other. And that is, I'm going to slice these off like that. And then we should have a tool. Hey! This is a 1, 2, 3 block. Let me get my watch out of here. There we go. This is a 1, 2, 3 block. There is a little bit of magnetic stiction here, but not much. All right, put the key in. Ooh, wow. Okay, I can move it with all my strength. I can move it about 1/8 of an inch. That's stunning, and that's off. Ooh. All right. Oh. Ah! Yeah! I am happy. I am super happy. I made a tool for a tool. The tool I bought is flat within 1 thou across its full width. That feels good enough for me for the kind of work I do in here. It's 25 microns, give or take. And I now have... Now I have 7 chucks for my lathe. And only one of them is a bullshit chuck. All the others are actually really good versions of such. This piece will come in handy the next time I have one of my cast iron kits to build. This is really great for that kind of thing. I'm really like, the whole magnetic chuck thing is pretty amazing to me in terms of being able to do work with a magnet. It's really incredible. Oh yeah. Yeah. Baby's got a brand new chuck. Thank you guys for joining me for this one-day build. Trying to think if there's something I'm missing. No, I'm not. Thank you guys for joining me for this one-day build. And thanks for watching while I added one more piece of equipment to my beautiful lathe. Keep building. I'll see you guys next time. Cheers.